Hi friends, new video lesson today on angle of depression and elevation. Honestly, basically the same thing we've been doing, a little different obviously, otherwise we wouldn't be having this lesson. But anywho, we are going to use these angles of elevation and depression to help us find measures in application problems, okay? So let's get to it. What is an angle of elevation? So when you look up to an object, the angle of elevation is formed by the observer's line of sight and the horizontal line. So like in our little picture here, here's our observer, this little guy, and he's looking up to the top of this, what is this called? Lighthouse? So this angle created with like where his eyes would typically be like looking straight ahead. Straight ahead, I don't know if you can see that, like straight ahead, and then where he's looking up, this angle created right here is called our angle of elevation. Okay, so this guy right there, that's our angle of elevation. And it makes sense, right? Your eyes are going up, like you're elevating something, it goes up. So angle of elevation. Which I'm assuming you could probably piece together that the angle of depression is when you're looking down to an object, right? So your angle of depression is formed by the observer's line of sight. So typically this lifeguard would be looking straight ahead. So that's his like line of sight. But now he's looking down at the swimmer. So this angle created between your line of sight and the object is your angle of depression. Now, the tricky thing is when we draw our triangles, our angle of depression isn't ever going to be inside our triangle. But what's nice is that we can fall back on previous knowledge to help us solve still. Because the angle of depression is congruent to the angle of elevation because they are alternate interior angles. So if you look here, folks, here would be a parallel line, and here would be a parallel line. Can you guys see that in the video? A little bit. And these two angles right here are alternate interior angles. So nerdy or not, I don't really care what you think. It is kind of cool. It's cool that we learned something back in November just to get a baseline of information, and now we can apply it to actual real life things. Like trig's very applicational, like we can use it in real life. So it's cool that now we can fall back on that previous knowledge and use it. So again, big takeaway here is your angle of depression is equal to your angle of elevation. They're the same because of alternate interior angles. So this first example here says label the numbered angles as an angle of elevation or depression. So we have these 4 numbered angles here. I think you should take a second, pause the video, and try it yourself as an angle of elevation or depression. And then you should check with me because I already know what they are, but you should try. Okay, I'm going to start. So if we start with the bird, here's the bird's line of sight, and he's looking down towards the hot air balloon. So this is an angle of depression. So I'm going to put a D. Now, if we're at the air balloon, for angle 2, he's looking up, right? He's looking up towards the bird, so that'd be an angle of elevation. Now, for angle 3, our observer is looking down towards the base of the mountain, right? So that'd be depression. And then there's nobody here, so I'll draw a person. The guy hiking on the base of the mountain is looking up towards the hot air balloon, so that'd be angle of elevation. Pretty basic, right? I hope. Okay, here we go. Our first little stab at this. It says a search and rescue team is airlifting people from the scene of a boating accident where they observed another person is in need of help. If the angle of depression to the person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to the person to the nearest foot? Okay, a lot to go through here. So give yourself a picture. The easiest thing with these problems is put yourself in the situation. It makes it a lot easier to like figure out what you're trying to do. So we have boating accident and people are being airlifted. Okay, so don't judge my drawings. We already know I have no artistic ability, but here we go. Here's my helicopter. I don't know, you guys. That's all I can do for you. That's my helicopter. Okay. And then what happens? There's a boating accident. The angle of depression to the other person is 42 degrees. Okay. Draw yourself a triangle because we always have a right triangle. Now we go through and read. If the angle of depression to the other person is 42 degrees, so our angle of depression, I should probably use a different color. Our angle of depression is 42 degrees. And the helicopter is 18 feet above the water. What is the horizontal distance from the person to the rescuers? So we're looking for the horizontal distance. And here is our boating accent. That's my boat. I'm sorry. That's all you get from me. Okay, so can we kind of visualize what's happening here? So again, our angle of depression is 42 degrees. The helicopter is 18 feet above the water. Here's our water. And we are looking for this horizontal distance. So now we got to label a few things. So again, this angle is not helping us at all being outside our right triangle. We need to put it inside our triangle to help us. So because we know these are alternate interior angles, 42 gets to go here. And now we have a problem that we've done many times already. So step one is we mark our angle. So mark your angle. Label your sides. 18 would be our opposite. X would be our adjacent. What trig function uses opposite adjacent? You should be thinking tangent. So tangent 42 equals 18 over x. How do we get rid of divide by x? Well, we multiply by x. X tangent 42 equals 18. Again, don't freak out. Tangent of 42 is just a decimal. It's just some random number in your calculator. So if we can multiply by it, we can definitely divide by it. And now it's just calculator work, folks. So if I take out the calculator for you. Oh, can't really see that though. Sorry. Okay, 18 divided by tangent 42. 19.9. So should we just round to 20 since it's 19.99? I think so. Oh, to the nearest foot. That's what it says anyways. Perfect. So our helicopter has a horizontal distance from 20 feet from the people in the water. We're going to skip the last example. It's a hard one. I don't want to do it over a video lesson. I don't think we're going to even get to it this year. So we're done. That's it for video notes. Thank you for watching. Have a super good rest of your day, and I will see you when I see you. Toodaloo.